Hello everyone. In this session, we'll be discussing bus arbitration, which is part of IO and memory in Unit 4. So, what is bus arbitration? So, you have different components of the components in the processor, and all the components are interconnected by using the bus. And when more than one component tries to access the bus, there must be some solution on who is to be given the authority over the bus for data transfer. Okay, so a conflict may arise if both the processor and the DMA controller or two DMA controllers are you trying to use the bus at the same time to access main memory. So to resolve these conflicts, an arbitration procedure is implemented on the bus to coordinate all the activities. So the device that is allowed to initiate the data transfer, we call it as the bus master. When the current master relinquishes the control of the bus, another device can acquire the status of the bus. And bus arbitration is the procedure by which the bus master is selected and bus mastership is transferred. The selection of the bus master must take into account the priority of the device. There are two approaches for bus arbitration. One is the centralized arbitration and the other one is distributed arbitration. In centralized arbitration, a single arbiter performs the required arbitration. In distributed, all devices participate in the selection of bus master. So first we'll see the centralized bus arbitration. So in a centralized bus arbitration, here you can see the arbiter circuit. So you have a single circuit, there are many IO devices, and here there is one master and another master. They wanted to access the bus, so they have sent the bus request signal. Bus request 1 from bus master 1, bus request 2 from master 2. So they all reach the arbiter circuit. Arbiter circuit will now decide whether to which is having a high priority, whether it is master 1 or master 2. And since it is master 1 is given a high priority, bus grant will be given to master 1. And then when master 1 receives bus grant, then it can start using the bus. And after it releases the bus grant signal, then master 2 will be given the bus grant signal. So here you can see how it is being given. So bus request 1 comes. So first bus request. So here there is three set of masters. So first request is received by given by master 2, bus request 2, then bus request 3, then bus request 1. Okay. So when bus request 2 is given, no other device has given the request, so arbiter gives grant to master 2 and it keeps on having, and it releases the bus request signal. Once it releases the bus request signal, arbiter releases the grant signal also. Now we have, if you see, there are two devices. 3 has also given, 1 has also given. Even though 3 has given first and 1 has given later, it checks the priority of device 1 and device 3 and finds that device 1 has higher priority and gives the bus grant signal to device 1. And bus device 1 uses the grant signal, transfers the data, and after finishing it releases the bus request signal. Then bus grant signal is released by arbiter, and then it gives the signal to bus grant 3 to device 3. So this is how centralized arbiter works. The problem with centralized arbitration is single point failure. So if the arbiter fails, no one will be able to use the bus. So we go in for distributed arbitration system. So in the distributed arbitration system, all devices can calculate whether they can use the bus or not by some simple calculation. So devices are connected to a common arbiter lines, and all devices are given an ID, and that ID will, when a device wants to communicate or hold request for the bus, or wants to use the bus, it places its ID in the arbiter circuit. Now, in the arbiter circuit, if more than one device wants to communicate, all will be placing their IDs in the arbiter line. So the final value of the arbiter line will be an OR operation of all the values. Now every device will be able to read the values in the arbitration line. So when they read the arbitration line, they will have to compare their ID with the ID value of the arbiter line from the most significant bit and decide if it matches with theirs, then they win the arbitration. Otherwise, they lose the arbitration. So, for example, if you take two devices, device A and device B. So they both place the value on the arbitration circuit. The arbitration line will have an OR value of this. So 0, 111 will be C. So now both devices will read their uh, 0, 111. They compare it with their own value 0, 101. So if you take A, it starts comparing from the most significant bit. Both are same, 1 is also same. Here 0 and 1, so it is 0 and it makes all the least significant bits 0. Same way, when you compare, so it becomes 0, 1, 0, 0. Compares it with the device A's code, it is not same, so it has lost the arbitration. Now we will see for device B, 0, 1, 1, 0. 0, 1, 1 is common, the last bit is 0, so it will be 0. So 0, 1, 1, 0 will be the value and it matches with its own code. So device B has won the arbitration. So this is how distributed arbitration works. Thank you.